shear lag factor. Shear lag u. Um, what was the equation for u? 1 minus x bar over L. What was L? The length of connection. For example, if we have a connection like this, if the connection is volted, L is the center to center length between first and end volt, or if we have welded connection, L is the length of, well, for example, like this. That would be L. What was X bar? When you want to find X bar, you have to see uh, side view. For example, we have channel, and this is our, for example, connected plate. First of all, you need to find the centroid of the member like this, and X bar is the distance between the plate and the center. Okay, let's have a look at this paper, at this table. Table D 3.1, shear lag factors for connections to tension members. Okay, here connections to tension members. Don't make mistake with other tables. For each part depends on your case. As I said, for example, if you have a plate connected to a plate, uh, if you have a plate connected to a plate like this, the one plate connected to another plate. This is the side view. Okay, for example, this is the plate connected to the other plate. In here, u is 1, so there is no need for any calculation. But if you have these cases, you should calculate u, and for other cases, depends on your case. You should uh, find u depends on your case. For example, let's have a look in this one. Plates where the tension load is transmitted by longitudinal belts only. Okay, I told you here, for example, let me show you here fasteners. Okay, in here you have fasteners. What was the meaning of fastener? Uh, bolt, like this. I told you bolt. So when you get a weld connection like this, you can't use this part. For welded connections, you should use these items, welds. Uh, for example, in this case says, all tension members where the tension load is transmitted only by transfer welds to some but not all of the cross section. To some but not all of the cross section. What does it mean? That means when you have transverse welds, again, U is 1. What was the difference between transverse weld, and longitudinal weld? For example, if you remember, I told you that this is a member, and this is another one. This is transverse weld, and this one is longitudinal weld. Okay. In this case, If you remember, for example, for this case, we calculate U. In this case, this flange, this leg, sorry, is not connected with this part, to this plate. Okay, so the connection is here. And what is this? Fastener. And we call it bolted connection. Bolted connection. For this case, you should find U. But what if we see a case like this? This is front view, and this one is side view. In this case, the connection is like this. On the table, it says all tension members where the tension load is transmitted only by transverse welds. So only, all we have is one transverse weld to some but not all of the cross-sectional element. So not all of, not all of, like here, not all of, just one. In this case, U is 1 again. Okay, so there is no need for to find U. Transverse welds are strong. Another case, plates where tension load is transmitted by longitudinal welds only. Okay, in this case, you should check if the length of the weld, look at here, the length of the weld, L is more than 2W or not. W is the width of the plate, and if L is more than 2W, so that means this length is long enough, U is 1. Is 2 is if L is less than 2W but more than 1.2W, U is 0.78, and if 1.W or look at here, check which of these three cases you get into. HSS, round HSS, single concentric gusset plate. This is another common type of connection. For hollow sections, especially for circular or uh, round HSS hollow section, it's not easy to connect. For example, this is a hollow section. If I want to show it in 3D, this is a hollow section. This, for example, for um, when you need when you need a strong column, mainly, it's better to use hollow section like tube or round, like this. We call them hollow sections. But how can you connect the plate to this section? You can't connect the plate like this or this. Okay, so the best way is to add a single centric plate like this. In this table, you can see that when you have a connection like this, you should follow this. This is the diameter, and L is the length of connection. And we mainly use weld to connect. displayed to hollow section. So it depends on your case. You should follow these rules. For rectangular HSS, you can either use centric or edge plates. Anyway, but if you can't, or if it's difficult for you to obtain U in under any circumstances, you have another choices. Number eight, number 8 and number 7. In these cases, instead of performing, instead of doing calculations, you can, for example, when you have 3 fasteners per line, or when you have 4 fasteners or more per line, instead of doing calculations, you can pick, for example, U.6 or U.8. Okay, for uh, single and double angle. So this is single angle, and this one is double angle. Okay, single angle, double angle. Single channel, single angle, single channel, double channel. For double channel, we can either use this shape, this arrangement, or this arrangement. This one is better, but you need space. You need more space for that. Okay. Depends on these cases. You can check, for example, for W, M, S, or HP. W is I, for example. T, this is T. I explained all of them. So it depends on them. You can pick one of them. For example, in this example, but you have to we solved this in previous class. If you remember, we found 0.72 as U. But if you use the last part of the table, where is that? This one. It's in this case we have how many fasteners do we have? Oh, maximum 3 fasteners per line. Yes. So instead of doing these calculations, okay, you can consider this one, single and double. So in here we got a single angle, and with 3 fasteners per line, maximum 3 fasteners. So there are 3 fasteners here, and we can use 0.6 like here. But you can see that if you follow this equation, your area would be 3.6. And if you use this simple way, this simple method, the area is 3. So if you want to get a higher capacity, higher reliable capacity, not just higher capacity, it's better to perform these calculations and not just take this line. So this is for example, for fast estimations, quick estimations, but it's not recommended. Do you have any question about this part? I'm gonna go to next part.
I don't.
Not.
Okay. So far, I talked about two criteria, failure criteria. What was the first one? For tension member. Each load regime has its own failure criteria. For tension, so far we talked about yield. What was the yield equation? Tn is equal to gross area dot yield stress. Second one was rupture. For rupture, Pn is Ae, that's Fu. For this one, phi or reduction factor is 0.9, and for this one phi is 0.75. Okay, and the final capacity PRN or PPN is 0.9 AGF1 BPN, or we call it R1. For this one, R2 or BPN 0.75 AEFU. Okay. What is the final capacity? R is minimum of R1 and R2. But after all of these criteria are checked, you have to check one more criteria, and it's called slenderness. Slenderness. What does it mean? For example, assume that this is a plate with this cross section, and you get another plate with this cross section. This one is slender, and this one is thick. Okay, what's the difference? The difference is the ratio. For example, this is L and this is F. The length is, the height is equal, but this one is A2, this one is A1, the cross section. The ratio of area or length per cross section is called slenderness ratio. Slenderness or slenderness. Let me write it in this way. Uh, does it matter? Yes, it matters. Why? Because you are not allowed to use, for example, this slender section for a column. It is obvious. Okay, what's gonna happen if a member is too slender? You'll have a buckling. You have, for example, failures in here. So under tension. So um, you sh it should be it should be a limit for slenderness. For tension members, the slenderness ratio is limited to 300. Let me see here. For members designed on basis of tension, so that means your member is under tension. The slenderness ratio, L over R, preferably should not exceed 300. This suggestion does not apply to rods or hangers in tension. Maher, what does it mean? What is hanger?
I don't know.
What uh, Abdul Hussain, what is hanger? Hanger is
I mean,
okay. Hanger is something for example, is a member that something hangs from it. For example, you need to uh, install some projectors, and you connect a member. You add a member and connect it to the roof. So you'll have a camera, for example, in here as a project. This member is hanger, so it carries something. For structure, we have other structural applications. For example, for removable roofs, uh, mm, for example, something that holds pipes in the roof. If you see, for example, we should add some hangers like this to install pipes, sewer pipes, or water pipes in your building, like this. So they are hangers. We use them to, okay. Anyway, let's see what is L over R. So as I said, L over R checks the ratio of length to area. What is L? Is obvious, it's length. For this member, for example, L is the length and R. What is R? Radius of gyration. Radius of gyration. What is this? It's the radius of gyration, if I'm not mistaken, is uh, I over A or A over, let me see, I forget. Radius of gyration is, uh, I forget the equation. I over A. Radius of gyration is I over A. But there is no need to find this ratio. If you check this manual, in R column, I explained this table and this manual, I think. Uh, Here, R. R is radius of gyration. So for example, L6.6 dot, for example, 1 over 2 that we talked about it uh, before, radius of gyration is L is 1.86. So this R here is radius of gyration, and L is length. So for example, if in our case, let me show in our case in here, uh, assume that the length of this member, assume that the length of this member is 12 feet. Okay, from this from the table, R is what? 1.86. R is 1.86 and L is 12 feet. Look at the units. 1.86 what? Inch. So if I want to check slenderness ratio, L over R, what would be 12 dot 12 divided by 1.86? So the answer is 12 dot 12 divided by 1.86, 77. And 77.4, are they good or not?
Clear, teacher.
What? Topic, what did you say?
Clear.
I no, I asked something. I said, how is the situation here? It's okay, not good. What? L over R. We got L over R 77.4. This is less than 300. So it is good or not? If we check, it says that it should not exceed 300. So this is less than 300 and we're good. So we're good. But for example, if you got 304, this is more than 300 and this is not good. Okay, so for generally for tension members, I want to give you a pathway. Step one. Step one, if I give you, for example, if I give you an example, solve. Step one, find cross section AG, AN, and AE. Okay. Step two, check yield and rupture. And you all know how to find. Step three, check slenderness ratio. If it's less than 300 or more than 300. Finally, the capacity is minimum of R1 and R2 and R3 that I'm gonna talk about it right now because we have another criteria. Also, slenderness should be less than 3. Okay, what is the third one? So far we talked about the yield and rupture. The last one that it's the last one is block shear. It's a little difficult, not difficult, it takes time to find. Block shear. Okay, let me see if I can show you some photos about block shear. Um, block shear. This is block shear. What is this? Doesn't work. This one is good. This is called block shear. Can you see it properly? Block shear. Block shear is a failure in which uh, a part of connection, it doesn't matter it's bolted connection or welded connection is ripped off from the rest of the connection. Okay, for example, like this. This one is, I think this one is better. Suppose that I should connect my VPN. Surely, right? Do you hear me?
Yes, teacher.
Yes.
Okay. Can you see this?
Yes.
Okay. Look at here. At first, everything is connected. Now we apply a tensile loading. This part is called yielding. Okay. But this part is called block shear. You can see that. This part, this member is completely fall apart from this one is completely taken apart from this. So it's like that. We have two separated models. What's the difference? We have couple modes, couple scenarios. The first scenario is this. You can see that the inside part remains here, and the external parts uh, took part. Okay, takes part. This is mode 2. In the second mode, the internal part takes part, but the outer part, the external part, remains. Mode 3. The difference between mode 3 and mode 1 is uh, in this mode, the connected plate, I mean the top plate, is the top plate is ripped off, and the bottom plate remains intact. So there is no failure in the bottom plate. But in mode 3, you can see that the top plate is okay, but the failure is inside the bottom plate. This is called what? Block shear. Let me see if I can show you better videos. Block shear of steel. I want to show you some realistic. This one, I think this one's good. Can you see it?
Yes.
This is block.
Yes.
I think so. I think that the idea about blood failure. The third failure criteria is black sheep. If you want to check blood sugar, you have to go through table chapter J. Let's see, there's blood sugar. There it is. Blood sugar. J4 part 3. Blood sugar. So to find or to check the blood sugar, you have to check this one. Point 6 FU A and B. U is 1. FU A and T. FY AGV point 6 and FU A and T. So you can see it's a little complicated, but it's not difficult. You just saw three, for example, different modes, different failure modes. Okay. For example, for this connection, let me make it too easy. This is the load. How was the failure? Mode 1, for example. Mode 1 was like this. In the first mode, we had something like this. Am I right? This is our gusset plate, and this is our member, our plate. Okay. First of all, what type of loading is between this edge and this edge?
Longitudinal.
Tension. Yes. This one and this one is tension.
Yes.
What about this one, this one, this one, this one, and this one? What's the loading here? What type of loading caused this failure?
Teacher, because cross section is low.
What?
Cross section
What
is
you say?
less than other part.
No, no. I mean, what type of failure in here? Tensile failure or shear failure? I mean, particular this one. What is this? This is tension. Okay. What is this? Shear. Yes. They in this one and this one slide against each other. For example, this is this is shear failure. Okay, from top and bottom. But from ends we have this failure. So this one is tension, but this one is shear. Okay, so this part is shear failure, and this part is tensile failure. Why do we need it? If you check this equation, you can see that in some parts we have V, A and V, and A and T, and AGV and A and T. A and V means uh, net area subjected to shear. A and T is net area subjected to tension. AGV is gross area subjected to shear. So that's why we
Sorry, we
need it.
can see share.
Uh, you sure? I'm sharing. Can you see now?
Yes.
As I said, in this equation, we have different parts. One of them is A and V, the other one is A and T, and AGV and A and T. I told you that A and T is net area subjected to tension, but A and V is net area subjected to shear. AGV is gross area subjected to tension, and uh, that's it. Now let's see what are these areas. For example, I'm gonna write it in 3D view. So this is our ruptured part. Now I'm gonna draw a part like this as well. Okay, these parts are same except that in this one there is no bolt hole or there is no hole. Okay. As I said, we have parts that subjected to tension and the other part subjected to shear. We should find three area: AGV, ANV, and ANT. AGV is gross shear area. What does it mean, gross shear area? Suppose that this length is L and this one is D. So what is AGV? The thickness is T. LGV for this part is L dot T. So this is AGV. And also we have another one in bottom part. So AGV is L dot T dot 2. What about A and V? Mahir, what is A and V? A and V is L minus this one and minus this one. So minus 1.5 D dot T, and as I said, we have another one in here, dot 2. This is called A and B. What about A and T? A and T is, for example, this length is W, is W minus D dot thickness. Okay, understood?
Yes, teacher.
Okay, that's enough for today. I'm gonna solve an example in the next class.
So can you upload YouTube this video?
Okay. Can't you
Because
download it from here?
Shahla has a problem with internet, and she said they upload this
Okay.
video YouTube. Thank you.
Okay. See you next time.
See you, teacher.
See you, teacher.